That has got to be the longest minute ever. That last minute before 2 hours UTC just stretches on forever and ever and ever. Hey, welcome everybody to Astronomy Daily Live. It's 2 hours UTC, just past 2 hours UTC, and it's time again to gather together this ever-growing group of friends from around the world and just sit back, relax, chill a little bit, forget about everything else, and focus on some astronomical stuff. So yeah, I hope everybody's doing well out there in the universe and the world. Carolina Sky Astronomy. Jim, nice to see you in the chat again. Tom, always great to have Tom there. Chuck, of course, always great. Hey, you guys, I owe you some music. I promise you it's coming. I promise. I promise. So it's coming. It's yeah, just well, you got to be in the right mood, in the right mode, and I'm set up to go over there. So it's just a matter of I'm pushing some buttons and stuff. So I will get on that. Don't be disheartened or anything else. I'll catch up. I'll catch up. And yeah, well, I like that kind of attitude. There's no real hurry, but yeah, it'd be nice to put something together here soon. So yeah, just I'm completely on it. It's just a matter of doing it. So, all right, well, great. Well, I hope everybody's doing well out there. As you can see, the sun is still shining here in southeastern Arizona, the United States. It's about 7:02 p.m. here at my location, yeah, well, good. Yeah, I think between the three of us, one person gets busy and is not able to do much, so the other ones can sort of catch up, and then yeah, I think that'll all balance out just great. And yeah, I mean, you guys are really good. So I'm in really good company. I'm glad about that. So all right, cool. All right, well, yeah, as you can see, and as I was saying, the sun is still shining here in southeastern Arizona, in the United States. The sun is going down. We're experiencing the beginnings of our monsoon season. It hasn't quite kicked in yet, but the clouds are here. So it's usually really cloudy until about, I don't know, 3 a.m. or 4 a.m. or so, right before sunrise. And then it just clears up. All the clouds vanish. Got this beautiful sky, and 10 minutes later, it's just too bright. So that is the typical monsoons. Yes, I'm on my weight loss plan. Every a couple of months, I've got to lose a little bit of weight here. So that's exactly what that's all about. It just it gets to a point where it's just starting to drive me insane. So off it comes, and I just do it the simple way. I've got an extremely simple life, no fuss, no muss. I've just got one of those wall shaving things, and we just knock it all down in just a couple of passes. All finished. There's a little bit of trim that has to happen, but yeah. So all right, well, great. I hope everybody's doing well out there. I've got the hydrogen hydroxide again here, HOH. Cheers. So today is July 16th, 2019, and around 21 hours or so, 18, 19, 20 hours UTC, something like that, a partial lunar eclipse is going to take place. And those of you in, excuse me, those of you in basically Europe, maybe a little bit east of that, you will have a very, very good view of this partial eclipse that is not a total eclipse, not the entire shadow of the Earth is passing right in front of the moon, just sort of a piece of it. We'll look at a map here, a, uh, a little diagram. So Chuck is saying that it's clear here, but the mosquitoes are out. So yeah, believe it or not, even here in the desert, we get mosquitoes. Now, they are not truck-sized like they are elsewhere, and they aren't so thick that you can't see, like across the street or anything. But we still, we have them here, and they like certain people more than others, and they and I sort of have a little bit of a deal. So they don't bother me much, and I don't bother them much. So it seems to work out for the most part. But again, the mosquitoes here are nothing compared to elsewhere. So I mean, it's hardly even. I'm not really able to complain about them. Not really. So yeah, pretty easy here. So yeah, we'll hang on to those mosquito nets and all that. Try to keep yourself back from having to spray yourself and all that. That stuff goes right into your skin, and I just it's creepy. To think about what kind of chemicals are going right into our skin like that. So, all right, well, I grew some. Cheers. Hey, nice to see you. Glad you could stop in for a little while. We're just getting going here, so grab your consumable of choice, whatever that is, whatever that might be. Mine, in this case, is the hydrogen hydroxide, HOH, but everything is welcome here, so cheers. All right, well, cool. So I thought maybe what we could do is actually take a look at that partial lunar eclipse that is going to be happening in a few hours. It's quite a few hours away, but it's not going to be until tomorrow evening for those of you in Europe. No, I've got that wrong. Okay. In Europe right now, it's sort of the middle of the night. So it's not going to be until tonight, right? That eclipse occurs. So yeah. So, but let's look at the little chart that NASA makes for all of these eclipses. They're really, really informative. Sort of a lot of information in a very, very small amount of space, and I like that. I like that a lot. So we're going to go over here and we'll take a look here. So partial lunar eclipse of 2019, July 16. Greatest eclipse is here. We can zoom in here a little bit. So the greatest eclipse is at 21:31:58 TD. Oh man, I don't remember what TD is, but anyway, here's the conversion to universal time. So 21:30. So that's sort of a local time. Well, yeah, for that time zone, that of course is 9:30 p.m. on the 16th. So 21:30, and it's about 2:10 right now. So we've got about 19 hours and 20 minutes until this mid eclipse, at least. So you can sort of see what's going on here. Here's the Earth's penumbra, this big gray circle. I hope you can see that. And here's the Earth's umbra. So this is the main shadow, and then because of diffraction and other things, you get this penumbra around it too. So it's not quite as dark as the umbra. And as you can see, the moon is going to be passing. The moon, it moves from west to east as it goes around the Earth, right? Now, whether it goes around the Earth or not, at least from this perspective, it is. So it is going this way. So that's what these P1, U1 things is. This is penumbra 1. This is when it first, the moon first makes contact with the penumbra. And I guess that's going to happen in 1843 UT time. And then, of course, the moon moves, and U1, which is first contact with the umbra, takes place at 22:01. So you can see that going from here to here takes about an hour and 15 minutes, hour and 16 minutes, something like that. Okay. And then, of course, here's greatest eclipse, and as you can see, the umbra of the Earth is only going to be covering maybe about 3/5 of the moon. The rest of the moon you'll still be able to see, so it'll be really, really bright here, and you'll have a dark part here. Definitely something worth seeing if you haven't already. If you've seen a lunar eclipse, and I sort of say this every time, it's like, when you've seen one, they're all pretty much the same after that, but it's still a really, really, really great thing to experience. So I do not discourage anyone from not going out and looking. So, but it's not going to be a total. It's just going to be a partial. So it's not. I suppose it's not quite as exciting as a full total. But I want to point out again, and I'm going to do this from time to time, because I'm getting absolutely no traction on this at all. I want to put a telescope on the moon and an operating observatory on the moon. I want it to be a commercial thing. I don't want it to be involving NASA or anything like that. Best to put it on one of the two poles, because that will minimize temperature fluctuations over the course of a lunar day, which lasts about 27 Earth days or so. So keep the fluctuations of the temperature at a minimum by putting this observatory either on the North Pole or on the South Pole or near that. And I want to point out that, if you're standing anywhere in this location on the moon, the entire Earth is going to block the sun, and it's going to look absolutely fabulous. And I want to be able to see that. So not only do I want to have a observatory up there with a sizable telescope, I'm talking about like a 0.5 meter to a 1 meter telescope observatory on the moon. I want to have some kind of maybe like a secondary set up some kind of a refractor or an all-sky camera or something up there to be able to view these lunar eclipses from the moon. It would be an absolutely spectacular view. So, and I think a lot of people would be really, really excited to see that. So, anyway, here's just another plug for putting an observatory on the moon. I'm getting absolutely no traction at all, but that's okay. You know, these kinds of things are going to happen. So it's just a matter of time. You know, if I'm doing nothing more, it's sort of, you know, just planting a little idea into somebody's head and say, hey, you know, we need an observatory on the moon, because you can do some really, really amazing things up there, observing in the ultraviolet, which you can't do from the ground. You know, the best I can come up with at the moment is imagine being able to do things like what Tess is doing, those long exposures. Well, if they want to, at least. You know, being able to observe the same patch of the sky for days and days and days on end, just over and over and over and over and over, in the ultraviolet. And you have a nice stable platform with the moon. And if nothing else, you have a destination. You have a place for humans to go. It's a place for human activity. You know, if you're into putting people back on the moon, they're going to have something to do, right? You just can't like walk around. You know, I mean, that's great for a while, but you're going to get tired. You're going to, I mean, it's hard to imagine, you know, but you're going to get bored after a while, you know, just walking around. So, you know, why don't you get to work? You know, this observatory is going to need maintenance. There's going to be a lot of dust. So you know, parts are going to have to be either cleaned or repaired. Anyway, I could go on and on about that. Just a simple little plug. Here's the visibility of the eclipse. So you can see that this portion here, so, you know, Eastern Europe and most of Africa, you know, the Middle East, a little bit of India there, is going to see the whole thing. And then it sort of, you know, degrades from there. And as you can see, us over here in North America, not going to see it. Now, those of you in South America are going to be able to see it, just at moonrise, though. So you know, you're not going to be able to I think, you know, be seeing the whole thing. But we over here in North America, if you're in Mexico or United States or Canada or Hawaii or Alaska, nope, not going to see this one. The moon just happens to be on the other side of the planet. That's how it goes. Yeah, that's how it goes. So, but, you know, the interesting thing, of course, about that is, if you think about it, also viewing from the moon, the portion of the planet that you are going to see is this dark part. You know, this is basically, you know, one half of the globe here, and so yeah, we may not be able to see the moon, but the moon is definitely going to be able to see us here in North America, for sure. And what a view that would be. We'd be able to see all the city lights. Wouldn't that be cool? Wouldn't that be just so cool, you know, to see that? I think so. All right, well, cool. So that's what's happening, what, in about 21 hours or so from now? That's when that, 21 hours? Do I have that right? Sorry, 19 hours. But it starts in about 16 hours and 43 minutes. So there you go. It actually ends on the on the 17th at 0:17 hours. So that's kind of interesting. That's when it just leaves the penumbra there. Yeah. Cool. All right, well, I'm going to look at the chat really quick, make sure that the shenanigans are flying. Yeah. Jim, that last lunar eclipse in January was absolutely fabulous. You know, I do the same thing every time though. I'm like, well, you know, it's just a lunar eclipse. I don't really care if I see it or not. But I always go out and I always watch, and I'm always like, wow, this is so cool. So, um, uh, Chuck, if that's happening, I think it's the other way around. I think the moon is going to occult Saturn, and I wouldn't be surprised. Everything is lined up, and it's happened the past couple of months. Somebody somewhere on the planet is seeing that. I think we can actually go. Well, there's Uncle Bill painting the chat yellow. Andy Cowley, hey, nice to see you. Glad you could stop in. No problem being late around here. We are easy. Yeah, you know, there are some pretty good arguments, you know, for having telescopes in space in general. You know, just getting out of the atmosphere solves a bunch of problems in terms of seeing and in terms of access to different wavelengths of light. What you really gain on the moon, at least the one thing that I've found so far, is that you can sit on a single target for, you know, like 13 days in a row, right? I mean, you don't have to stop at all. So you know, that makes for you know, some possible really interesting things. And if you had, you know, basically, you know, the resolving power of the HST, the HST is about a 2.3 meter telescope or so. What I'm talking about is about a meter or less, something sizable that can be actually really used. There are telescopes up there. Well, there's one right now being operated by the Chinese Ching 3, and I think it's 100. Yeah, I think it's 15 centimeters. So it, you know, it's like a 6-inch scope, and you know, that's okay. It's all right, but you know, and they're actually doing some really great work. They actually have some publications, and that's been up there for like 4 or 5 years now. So that's happening. The International Lunar Observatory Association, ILOA, I think if you look for iloa.org, they are planning on putting up a 7-centimeter telescope on somewhere near the South Pole. They're going to hitch a ride with Rocket Lab, I believe, at this point. So, you know, there are going to be, you know, some scopes on the moon, but oh, come on, we need something sizable that professionals can actually, you know, use and want to use, and you know, say, hey, you know, we want to buy some telescope time. Hey there, F20, how are you? Nice to see you here. So we're talking astronomy here, just plain old, good old astronomy and science and spacey things, that kind of stuff. We're just looking at the lunar eclipse that is going to be happening here relatively soon. If you're in sort of Eastern Europe or Africa or the Middle East, you'll be able to see the whole thing. If you're anywhere else, you're either going to see a little bit of it or none of it at all. So, if you're in this dark area, not going to see it at all. But if you're anywhere else, you'll see at least a piece of it, if not all of it. So yeah, well, cool. All right, I'm gonna keep an eye on the chat here. Yeah. All right. Well, the other thing that I thought, since we're sort of you know, thinking about eclipses and stuff, whenever I do that, I always think about the sun. And one thing that we haven't done in a little while is go over to the IRIS uh, website and take a look at their data over there. So this is a sun synchronous orbit satellite that is going around the Earth, and sun synchronous means that it's always or almost always able to view the sun. So it's sort of in a polar orbit, and it is almost constantly looking at the sun. And these folks are really, really great. They put their data out in a very, very, very timely fashion, and there's a lot of it. There's just so much. So here is sort of the latest, and I'll zoom in a little bit here. Here's the latest that they've got, and as you can see, this is from from July 15th. Oh, excuse me. Going from 9:37 to 11:40 UTC. So that was what? Well, we're at 2:26 UTC on the 16th right now. So what is that? That's it's almost 24 hours ago, but wow, that's not too bad. Now, most of the data, the science data, isn't quite ready yet. These are usually FITS files that contain the images and the spectra and all of that. This is a really, really cool instrument in that it's an 8-inch telescope, right? It's just this little tiny scope, just like the one I've got behind me, but it's got a slit right down the middle of it, and that slit acts as an entrance slit to a spectrograph. So they can simultaneously take images and spectra of various locations on the sun, and it's amazing how incredibly dynamic the sun is. What I thought I would do is actually let's try to go back in time. IRIS has been around for quite a long time. I forget now exactly when IRIS launched. Can we should be able to find that out here? Mission. See, I'm not seeing anything. Here's a picture of IRIS. Well, and here's a diagram of it. So here's the scope in here, and then here's everything else. So pretty amazing. I don't remember when this launched, though. Can we? This doesn't really give a lot of info in terms of when it was launched. Maybe somebody can look that up and let us know. The other thing that I wanted to point out was that Tom has done an On This Day today. So on this day, 1943, Jocelyn Bell Burnell was born. She's the pulsar lady. She first made this discovery apparently back in 1967. And of course, her contributions weren't enough to earn the Nobel Prize. The people who I believe she worked for got that. So yeah, She probably deserves it. I thought, I think things are beginning to turn in that area. At least I hope so. Um, and I'm thinking maybe was she? I know there was another lady who just received sort of a posthumous Nobel Prize for her work when she wasn't recognized either. I don't think this is the same lady, um, but yeah, we'll see. And Jim, I think that's one of the reasons why I sort of want to go back in time with the data, because this is really interesting, but it's sort of mundane. We want to see, we want to see a little bit of action here. So let's go all the way back to beginning. Is this the beginning? Yeah, I think it is. 434, 719, 720, 718. Oh, there's blackness there. Banner annotation. So here, is this the first one? I think this is the first one, 717, 2013. Does that make sense? Iris launched June 27th, 2013. So on July 17th, 2013, they took their first image and maybe even some spectra. Oh, just looks like a simple, plain old image. Looks like they have a, well, let's see what this does. Uh-oh. See if it wants to load. Yeah, here we go. I'm going to zoom out a little bit. See the whole thing. Oh, there's only 10 images here, so you can sort of see. So here's, of course, the image of the sun. Here's the slit right down the center of the mirror. So, light from this area of the sun, just this area here, goes into the spectrometer. But yeah, that looks like at least the first public images that they put out. And it's probably hard to see from where you are, but yeah, the sun is just boiling underneath here, so that's pretty cool. So that's the first publicly released observation. Here's another one, pretty short one again, but they're getting more sophisticated. They're actually looking at spectra now. So okay, and they're looking at it in 2 different wavelengths as well. So well, let's take a look at this. This is kind of neat. You can see the spectra here too, the emission lines that they're seeing. So let's see what this does. So again, okay. So this is like 2 images. Okay, that's not incredibly exciting. Let's see if this is any more exciting. Oh, there's just 2 images there too. So obviously they're just wanting to get some spectra this time. I'm really not seeing any movies of the spectra yet. So yeah, well, we can keep moving. There's more. So yeah, that's where it sort of started. They started looking at the limb here a little bit. 6 images there, it looks like. Okay, so let's move forward in time a little bit. Get out of sort of preliminary mode into operational mode here at some point. So we're getting into August. And I can't really tell. Oh, here's 388 images. Ooh, here's a nice one, but there's only 8 images there. let's look at that anyway, just for fun. That's a nice prominence there, but yeah, it's only 8. It's only 8 images, so that's okay. So not a lot to see there. You're starting to see some dynamics there a little bit, but let's keep looking here. It's back in 2013. Of course, the sun was pretty active still. It was what was that, like 6 years ago? Wow. Let's see if we can get any interesting looking prominences here. That's what I'm sort of looking for. Sort of a lot of images and looking on the edge of the sun. So, you know, they are doing what they should here, and they are looking at active regions, sunspots on the surface of the sun, on the face of the sun. Let's see if we can find some that sort of on the edge of the sun. That's where we'll see some prominences and a little bit more action. Sometimes these are a little bit hard to see what's going on exactly. So I'm gonna check the chat here really quick. Hopefully all the shenanigans are going on. Good. I like it. Well, let's see. We'll go even forward even more here. There's so much that it's overwhelming. 1,198 images. Wow. Should we look at that? So they're calling this a medium sparse raster. So this shows where on the sun they're pointing, and this is offset from the center. So they're 115 arc seconds left of center and 230 arc seconds below center. I think sometimes they show a context image. Is that? No, that's not what that is. They show it in terms of the whole sun. I'm not seeing anything like that here. But let's see if we can load this. I mean, it's probably, yeah, that's a lot of images. And so what they do, and as you can see, what it's doing here is it's sort of scanning, what they're calling rasterizing. So, you know, they're able to sort of view a little larger portion of the sun than what they normally would, and they're able to look at a lot more area of the sun with spectrograph. So that's always nice. So we'll let this load. It's got 1,200 images to load, so this poor thing is about 10% done. So we'll just let that load, I guess, a little bit. Let's see if there's anything else going on in the chat. So yeah, not much action at the moment in terms of you know, big time action. Always action going on the sun. It's a, you know, we don't have, I don't think, a very good understanding of you know, the sun and how it works. I think over the next several years, hopefully, you know, our perspectives will change a little bit. We'll evolve a little bit more, and we'll sort of hopefully gain, you know, some deeper understanding as to what is going on with this thing, because it's a pretty amazing object, of course. So, all right, this is up to image number 300 out of 1,200. So we're getting there. It's kind of neat to see it this way, you know, kind of forming image by image. But it's always great to see it when it actually starts running, because you really get to be able to see things moving, see lots of material moving around, and the sun is an amazing place. So cheers to the sun. I'm going to take a big gulp of this HOH here. Cheers. Ah, all right, great. Let's see. While that's loading, we can sort of keep scanning around and seeing if we can find any things with prominences. So, all of this is really, really great to view, and it's nice to have access to, the actual science data here. I think that's absolutely fabulous. But, unless you're sort of specifically looking for something, it's best just, to look at the interesting things, at the exciting things. And we're just sort of tourists here, so we want to look at sort of the cool stuff, the interesting stuff. So it looks like this is right next to it looks like a sunspot over here on the right, just coming in to view. So yeah, of course, they look all around to see what's going on there. And because this is loading, these are all taking forever to load. So yeah, that's just bandwidth. Let's see, we're almost halfway. We're about halfway now with this. So that's not too bad, I suppose. Let's see, we can't really get a lot of info here except for the text. You can see, they've moved. Now they're to the right and above the center of the sun. But there's a lot of other info here. Looks like they're doing specifically some spectral work, some long exposures. Wow, 10-second exposures? Is that what we're seeing? Why do you need a 10-second exposure when you look at the sun? I don't know. 10-second exposure, 6-second exposure, maybe a 20-second cadence for what they're calling a wobble calibration. So maybe they're just taking calibration data here. That's kind of cool. There's a link down here called All Movies, which is sort of intriguing. Oh, we're up to 750, so we're almost there. These things haven't loaded yet. I feel like a sports commentator, these images haven't arrived yet, but we have a field of view of 173 by 180 arc seconds. Yeah. So here's a little bit more info here on so I think what this is saying is that, they're scanning across like they are here, and they're doing it in 64 steps. 2 arc seconds per step, and then each. Yeah. Oh man. Yeah. I'm not quite sure how to read this. I guess there's a lot of time here. Not a lot of images here. So almost there. Ooh, almost there. Should we hang on this? This is definitely not going to be the most exciting one that has ever been seen, but it's definitely worth seeing, especially if you haven't seen it before. So as I said, this dark line is the entrance slit to the spectrograph, and so as this thing scans, it's both getting spectral information along the y-axis of the sun and also along the x-axis of the sun. So they can do a lot spectral analysis on a pretty large portion of the sun. Okay, it looks like we've got about 100 images left. We're almost there. Almost there. Here we go. 100 left. I'm on the edge of my seat. I don't know about you, but I certainly am. Here we go. Just a few more now. Once this loads, it'll run really, really fast because it's in a cache, of course, on my local machine. Making this machine work pretty hard here. That's okay. That's what these machines are for, to work hard, crunch numbers for us. Here we go. Bam. So actually a pretty stable area, but you can see all this stuff flying in between. Look at this here. It's like rivers, just rivers of material. And I guess the idea is that this material is following these complex magnetic fields. So yeah, we haven't even watched the full movie here yet. Here, I'll back out a little bit more so we can see the whole thing. But as you watch this, you can really see things. Okay, there we go. There's our loop. So that's a nice long sequence there. And if you look at the details, here, I'll zoom in here like crazy. Let's see if this works. There we go. So we get it. So you can see all those little things. Now, each pixel here is, I would say, hundreds or thousands of kilometers in size. I mean, we're still looking at some very, very, very large structures here. Really, really, really huge. But still, pretty amazing how much action, even on this scale. Can you imagine what it looks like at like a kilometer pixel size scale? I can't even imagine that. Can't even imagine. I think the Parker Solar Probe has some cameras on it that'll, I think, probably provide us with the highest resolution images of the sun we've ever had. Here's kind of a nice area. You can see a little, I'm not exactly sure what that is on the image itself, but it's part of the system, not part of the sun. But you can see all kinds of things are going on in here all the time. Busy, busy, busy place. And of course, I've got this severely magnified up so you can see all the gunk. I like to see all the gunk. I don't mind that at all. People who just want to see all the pretty stuff, they're missing out. They're missing out because this is the real deal here. Look at this stuff just sort of floating off here. Look at that, just oozing. They've got timestamps on these. Sort of see what we're dealing with here. We can pause this. So that's at 1:02:33 on August 21st, 2013. Here we go. Thought we could go just one step. Yeah. Okay. So 1:02:33. Next one's 1:02:36, 39. Wow. So this is every 3 seconds. So every 3 seconds there's an image. So, now that you know that, you can sort of get an idea about how fast this material is moving. So, you know, some of these things, you know, are moving maybe 1 pixel every couple of frames. So that's like 1 pixel every 6 seconds, 10 seconds or so. And if 1 pixel is 1,000 kilometers, that's 100 kilometers a second. So I don't know what the pixel size is on these. I don't remember. Maybe somebody in chat, if you know, can find out. All right, well, cool. I'm going to pause that. And here's an edge with a little bit of prominence there, but it's not too exciting. Let's see what we've got over in the chat here. Oh, machine is, I'm going to have to kill this. Thank you, son. You look pretty good that day. But you're going to have to go away because you're freezing up my machine. Oh, yeah, it's not too happy. There we go. Yeah, she's Kira H. Howdy. Yeah, she's out with the telescope, right? Exactly what she should be doing. So yeah, hopefully she'll be back soon. But yeah, she's playing with the scope. So I think she's trying to get her revolution system running so she can look at things on that screen. I think she's really jazzed about that. So, all right, let's see if there's anything else here. I'm really looking for prominences, some active prominences. So I'm really skipping around now, but we've gone back in time. We're back in 2013, September of 2013 with Iris. It's when the sun was a little bit more active, so I'm hoping that we get sort of lucky here in the next couple of minutes. And yeah, there's something. There's only 187 images there. I'd like to have a few hundred. Looking at the edge of the sun. Well, yeah, man, can we do better than that? One can spend hours and hours and hours doing this, of course, which I have done. So this is looking off limb. 300 images. Yeah, let's look at that. Yeah, that might be pretty interesting. Yeah, so let's try to load this. See what happens. A little bit of action here. Not going to take too long to load. Watch. You see that the spectrograph slit is way out here. So the spectrograph isn't seeing anything at the moment. But I think when these prominences pop up and, you know, get over here, a little bit of that light is going to be going into the spectrograph, and you'll actually be able to see, you know, the spectrum of one of these prominences. But yeah, wow, that just sort of formed out of nothing. That just formed out of nothing. So what's going on there? Where is this material coming from? It's materializing out of what seems to be nothing, nowhere. How do you figure that? Okay, so here's the whole thing. Yeah, just sort of forming like that, huh? How do you figure that? I don't know. Pretty neat, though, of course. Let's see, do we have... It'd be nice to show off these movies, but I think I would have to... Yeah, I think I'd have to do that in slightly different way. That would take a little bit more time than what I want to do here. So let's go back or forward in time a little bit more. You can see anything. There's a little bit of prominence there. 350 images. Should we look at that and then call it? Which one should we do? Let's do this one. This is at, I guess, 1330 angstroms. So ultraviolet, of course. You can see a little bit of the spectra here, too. These are the magnesium-2 lines. This is the silicon-4 line. This is the oxygen. It's oxygen. I think it's oxygen 3. It's either oxygen 3, oxygen 2. These are carbon lines over here, so they're sort of focused on those. But now let's look at this. This is 350 images total. Looking at a little bit of the edge of the sun there. It's always kind of interesting to see the edge. You see how busy everything is everywhere else. So this will take a couple seconds to load here. Go back onto the chat, make sure that the shenanigans continuing. Yeah, and in fact, we're going to start feeling the, well, if our idea of how the sun is evolving is true, then we're actually going to, and I say we, but whatever's here, is actually going to be starting to feel those effects starting in about 200 million years. So the sun is supposed to go to its next evolutionary phase in a few billion years, but it's going to start. I mean, it's constantly changing. It's changing now, but over the course of 200 million years, we will definitely start noticing that things on the sun aren't quite the same. So I, for one, am definitely making plans. I've had to change my plans because for years and years it's like, oh, I don't have to worry about the sun for at least a couple of billion years. Well, no. In 200 million years, the sun is supposedly going to be changed enough such that we will definitely feel its effects here. Don't think that big bright star in the sky is not affecting our climate in a major way. We humans are definitely polluting this planet and messing up the climate that way. But in terms of what makes the climate go, it's this dude right there. Or dudette, don't exactly know. There's an interesting idea that the sun is some form of living being, maybe even sentient. Who knows? Anyway, so there it goes. You can see that's some nice action off the limb here. You got these things. These are called spicules, and this is what they do. They just sort of shoot up and then fall back down. Just bing, 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 bing. And these are spicules too. All these things here. It's just, we're seeing these on edge, and these, we're seeing at a um, less of an angle. So, you know, we don't really see them popping up, but that's exactly what they're doing. And so, yeah, lots of action here. And as with this, you can see that they aren't scanning. They're just leaving spectrograph in one particular location with the sun and just getting all the y-axis here, right on the edge of the sun. So very cool. Zoom in a little bit on those spicules. You know, this is an 8-inch telescope looking at the sun from the distance of the Earth. So your resolution is not going to be all that great. I think the resolution in the actual science data is a little bit better. These are probably JPEGs or something. So the resolution is slightly better, I think, with the raw data, the actual science data. So, okay, well, you know, that's a nice visit to IRIS. IRIS is a great instrument. As far as I know, it is a continuing thing. So I don't think it's going to be going away anytime soon. I think they probably do have some limitations in terms of lifetime, but I think they're still pretty gung ho. Correct me if I'm wrong on that, please. But yeah, I think for now, I'm noticing that it's about 3:01 UTC. So yeah, I think we've done a good hour here. I still have a little bit of this left. So cheers. Excellent. All right, everybody, I think I'm going to get out of here for now. So have a great evening, a great day. Peace, cheers, and all that. Live long and prosper. I'll be back again here tomorrow, 2 hours UTC, doing more astronomical stuff. Who knows what it is? I don't really have any plans. So, if you have any ideas, let me know. Yeah, I think that's it for now. I'm out of here. All right, everybody. See you later. Take care, and I will see you on the spin. See you later. Bye.